Hi everyone. In today's lesson, we're going to talk more about long division and its applications. So example number one is saying use long division to factor f of x completely if this is f of x and if f of x has a factor of x minus 2. So a lot of you are probably reading this and wondering, well, why can't I just factor it, right? Didn't I learn factoring? Why am I bringing long division in? So let's just take a look at this polynomial. We have 6x to the third minus 19x squared plus 16x minus 4. And I've got four terms, and if I try factoring, factoring would look something like grouping, right? There's four terms here. We bring down the sign in the middle. So the GCF between these first two terms, I'm thinking is just x squared. So we take out the x squared, and we're left with 6x minus 19, sorry. And the GCF of the second two terms would be 4. So I take out a 4 and I'm left with 4x minus 1. And the normal next step of grouping would be to take out the common GCF factor here. But what you're noticing is that these two polynomials, or sorry, these two binomials here, they're actually not the same. So there's a problem. We can't continue to factor using grouping. So we can't factor this. So how else are we supposed to find the rest of the factors, right? The question is asking us to factor f of x completely. So since we can't factor, we kind of have to think of another approach. So in order to do this, they have to give you this information here. They have to tell you that x minus 2 is a factor. So since yesterday we learned that if x minus 2 is a factor, the remainder must be 0. So let's go ahead and actually do that long division. So the x minus 2 can go on the outside, and then we have 6x to the third minus 19x squared plus 16x and then minus 4. So I'm not going to bore you with the long division. Why don't you guys pause the video and do the long division and see if you get 0, and then hit resume when you're ready. Okay, here's the answer. All right, so you see how you got a remainder of 0 here? So because we have that remainder of 0, that implies that not only is x minus 2 a factor, but so is this, right? It kind of reminds me of long division from when we were kids, right? If I want to figure out how many times 4 goes into 20, we know that it goes in 5 times. 5 times 4 is 20. We subtract and we get a remainder of 0. So what happens is that both 5 and 4 are factors of 20. So in this case, we now know that this and this are both factors of this original polynomial right here, right? So let's write it down. The factors are going to be x minus 2 and 6x squared minus 7x plus 2. And if I want to factor completely, I need to check to see if I can factor this trinomial a little bit more. And this reminds me of AC because the leading coefficient is 1. So I'm going to go ahead and do that factoring over here. So I have 6x squared minus 7x plus 2. And I'm going to multiply the first and the last. That gives me 12x squared. And I want to find the factors of 12x squared that are going to add to this middle term of 7x, or negative 7x. So the factors that come to my mind are negative 3x and negative 4x. Negative times a negative is a positive, and negative plus a negative adds to another negative. So we're going to go ahead and rewrite the negative 7x as negative 3x minus 4x, right? And then we're going to bring down my last term and bring down my first term. And we're going to factor by grouping. Group the first two, group the second two, and bring down the sign in the middle. The GCF of these first two terms looks like a positive 3x, and I'm left with 2x minus 1. The GCF of these second two terms looks like a 2, so because I'm bringing down the negative, I'm taking out a negative 2, and I'm left with 2x minus 1 again. And since the 2x minus 1 is the same, that gets its own parenthesis, and the stuff on the outside gets its other. So that would be 3x minus 2. So to factor completely, we get 2x minus 1, and 3x minus 2. And then don't forget to bring down this x minus 2. And this would be my final answer for the factors. Okay, same question. I know it didn't ask to do this, but what if it asked to find the roots? So we have the factors, and that is x minus 2, 3x minus 1, and 2x 1. Sorry, and this is 3x minus 2. So if those are my factors and I want to find the roots, right? Remember, all we need to do would be set it equal to 0 and do a t-chart. So this would be x minus 2 equals 0. So we would add 2, right? And this root would be x equals 2. Then we have 3x minus 2 equals 0. We'd add 2 to both sides. So 3x equals 2. Divide both sides by 3, and we get x equals 2/3. This would be another root. And 2x minus 1 equals 0. We would add 1 to both sides, and then we would divide by 2. So this would be my other root. So not only can we use long division to factor something completely, but we could use those factors to find the roots if we set each piece equal to 0. Okay, I'd actually like you guys to try number 2 on your own, and then hit resume when you're ready for the answer. Okay, here's the work for the long division. Take a look at it and make any corrections that you need to at this point. All right, so from what you can see, we do have a remainder of 0, so that implies that this is a factor and this is a factor. So if I wanted to find my factors, I'm going to first start by writing x plus 3 times 2x squared plus 5x plus 3. And I'm thinking I can factor this trinomial a little bit more like I did before. So I'm going to take this 2x squared plus 5x plus 3, and I'm going to factor by AC because the leading coefficient is 1. So 2x squared times 3 is 6x squared. And the factors of 6 that are going to add to 5, I'm thinking are 3x and 2x, right? 3 and 2. So we have 2x squared. Rewrite the 5x as 3x plus 2x, and then bring down the 3. And then factor by grouping, group the first 2, group the second 2, and put the plus sign in the middle. So the GCF of these first 2 terms are x, and I'm left with 2x plus 3. The GCF of these second 2 terms is just 1, and I'm left with a 2x plus 3 again. So the 2x plus 3 gets its own set of parentheses, and the x plus 1 gets the other. So then my final answer for factoring completely would be x plus 3, and then 2x plus 3, and x plus 1. So these would be the factors of that polynomial. Now, I know it doesn't ask for this, but how could I use this information to find the roots? So why don't you try that part on your own, and then hit resume when you're ready for the answer. Okay, so you have needed to have taken these parentheses and set them equal to 0. So x plus 3 equals 0, minus 3 on both sides, and you should have gotten x equals negative 3. 2x plus 3 equals 0, minus 3 on both sides, and divide by 2. So you get x equals negative 3 halves. And then x plus 1 equals 0 gives me negative 1. So if the questions ask, we can not only use long division to find the factors, but we can ultimately use long division to find the roots as well. All right, that's it for tonight. If you guys have any other questions, please jot them down and ask us in class tomorrow. And have a great night.